Have you ever wondered why some data can be averaged while other types can only be counted? The secret lies in understanding data measurement scales. In the world of statistics and data science, truly unlocking the power of your information hinges on knowing exactly what kind of data you're working with. Getting this wrong can lead to flawed analysis, misleading conclusions, and ultimately, poor decisions. Imagine trying to calculate the average color of a car or saying that a temperature of 40 degrees Celsius is twice as hot as 20 degrees. Intuitively, these statements feel off, right? That's because different types of data require different statistical treatments. Properly identifying your data's scale of measurement is the foundational step to choosing the correct statistical tests and deriving meaningful insights. Today, we're going to demystify the 4 fundamental scales of measurement: nominal, ordinal, interval, and ratio. Each scale possesses unique properties that dictate how data can be collected, analyzed, and interpreted. By the end of this explanation, you'll have a clear roadmap for handling any dataset that comes your way. Let's start with the most basic, the nominal scale. Nominal data, derived from the Latin word nomen meaning name, is all about categorization. This type of data simply labels or categorizes attributes without any inherent order or ranking among them. Think of them as mere tags. There's no numerical value or quantitative meaning attached to these labels beyond identification. Classic examples of nominal data include gender, marital status, colors, or types of fruit. While you can assign numbers to these categories for coding purposes, like 1 for male, 2 for female, these numbers are purely arbitrary placeholders and do not imply any order or magnitude. You can count the frequency of each category, but you cannot perform mathematical operations like addition or averaging. Moving up in complexity, we encounter the ordinal scale. Ordinal data still deals with categories, but with a crucial distinction: these categories have a meaningful order or rank. While we know the order, the differences or intervals between these ranks are not uniform or quantifiable. We can tell that one category is more or less than another, but not how much more or how much less. Consider common survey questions like satisfaction ratings, educational levels, or economic status. We know that very satisfied is better than satisfied, but the psychological gap between very dissatisfied and dissatisfied might not be the same as between satisfied and very satisfied. You can determine the mode and median for ordinal data, but calculating a true mean would be inappropriate. Next, we arrive at the interval scale. This scale represents a significant leap forward because it introduces measurable differences between values. With interval data, the order matters, and the intervals between values are equal and meaningful. This means you can quantify the difference between any 2 data points. However, the critical characteristic of interval data is the absence of a true 0 point. The most frequently cited examples of interval data are temperature scales like Celsius and Fahrenheit. The difference between 20 degrees Celsius and 30 degrees Celsius is the same as the difference between 30 degrees Celsius and 40 degrees Celsius, a 10-degree change. Yet 0 degrees Celsius or 0 degrees Fahrenheit doesn't signify the complete absence of temperature, it's just an arbitrary point on the scale. Similarly, IQ scores are considered interval data. An IQ of 100 is higher than 90, and the 10-point difference is consistent, but a person with an IQ of 100 isn't twice as intelligent as someone with an IQ of 50. Because there's no true 0, ratios are not meaningful. Finally, we reach the most informative scale, the ratio scale. Ratio data possesses all the characteristics of interval data: order, equal intervals, but with the addition of a true, meaningful absolute 0 point. This true 0 indicates the complete absence of the characteristic being measured. The presence of a true 0 allows for the calculation of meaningful ratios. Think about common measurements like height, weight, age, income, or the number of products sold. A person who is 180 centimeters tall is indeed twice as tall as a person who is 90 centimeters tall because 0 centimeters represents no height. Earning $100,000 is genuinely twice the income of earning $50,000. With ratio data, you can perform all arithmetic operations, addition, subtraction, multiplication, and division, and derive all standard descriptive statistics, including the mean, median, and mode. The distinction between interval and ratio scales can sometimes be subtle, but the key is always the true zero. If zero truly means none of the quantity being measured, you have a ratio scale. If zero is just another point on the scale, perhaps indicating the absence of the property being but not its, then it's an interval scale. For instance, while a score of 0 on a test might mean no correct answers, it doesn't mean the test taker has zero knowledge or ability. Hence, test scores are often treated as interval, not ratio. So, why does all this matter? The type of measurement scale directly determines the appropriate statistical analyses you can perform. For nominal data, you're limited to non-parametric tests like the chi-square test, and you can only report frequencies and modes. For ordinal data, you can use non-parametric tests that consider rank, such as the median and rank order correlations. When you move to interval and ratio data, you unlock the full power of parametric statistics. Here, you can calculate means, standard deviations, and employ powerful inferential tests like t-tests, ANOVA, and regression analysis. Using a statistical test meant for ratio data on nominal data, for example, would produce utter nonsense and potentially lead to severely misleading conclusions. Understanding nominal, ordinal, interval, and ratio scales is more than just academic knowledge, it's a critical skill for anyone working with data. By correctly identifying your data scale, you ensure the validity of your analysis, the integrity of your conclusions, and the effectiveness of your decisions. So, the next time you encounter a dataset, pause and ask yourself, what scale is this data on? Your analytical journey depends on it.